Welcome and thank you for joining me. In this lesson, we'll explore the transformations of the reciprocal of primary trig functions. And as an example, I have considered the function y equals 2 cosecant 1 over 3x minus pi over 2 plus 1. Step number 1, just like we do with graphing any functions, is factor out the coefficient k. The coefficient k is the number in front of x. When we have x, the variable x, attached to its coefficient, and then we have plus or minus some other constant number, it means that it's not in factor form. So we're going to write here 2 cosecant. So in our case, the coefficient is not factored, so we'll take out the coefficient of 1 over 3. And then obviously 1 over 3x will become an x, right? And negative pi over 2 will also change because we've taken out 1 over 3. And the way we figure out what it has changed into is by dividing by the coefficient 1/3. So dividing by 1 over 3 means that you're multiplying by the reciprocal, 3 over 1 in this case, which will change this to negative 3 pi over 2. So we have minus 3 pi over 2. And then plus 1 at the end. So in order to graph the reciprocals of primary trig functions, we first build the graph of its respective primary. So in our case, we have cosecant function, which is the reciprocal of sine. So we'll start off by drawing the graph of y equals 2 sine 1 over 3, x minus 3 pi over 2, and then plus 1. So we identify the coefficients. So the coefficient A is 2. The coefficient K is 1 over 3. The phase shift is whatever number we subtract from x. In our case, we're subtracting positive 3 pi over 2, so that will make the phase shift. And the value of C, which is the last number in the equation, I don't know why I wrote C here, it's plus 1. So that would be 1. Now the period length is measured as the ratio of the basic period for the sine is 2 pi divided by the coefficient k. So in our case, the period length would be equal to 2 pi divided by 1 over 3. So it seems that here we have a wide period length. It's a horizontal expansion. So 2 pi multiplied by 3 over 1, which makes the period length 6 pi. The equation of the axis of symmetry is always at y equals vertical translation, which is dictated by the coefficient c, and we're going to say that axis of symmetry is at 1. The maximum value of the sine function is measured as the value of C, the axis of symmetry. So we start at the axis of symmetry and we go up by the amplitude. In our case, we have 1 plus absolute value of 2, which means that the maximum will be 3. And the minimum is determined as, starting from the axis of symmetry, we go down by the amplitude, which means that 1 minus the absolute value of 2, which is 1 minus 2, or negative 1. So we start off by drawing the graph of the primary function. And as you see here, we have quite a wide period, and we have a horizontal translation by 3 pi over 2, which means that we're going to need a lot of room in the positive x values. So what that means is that we need to draw the y-axis right on the edge of the space here. Now, the vertical translation is 1 up, which means that we're going to have more graph on the positive y values than in the negatives. So this would be the y and this would be the x-axis. So the way we set up the x and y-axis makes the graph easier or difficult to draw. So the way we want to work with is starting from the phase shift, which is 3 pi over 2. So you see that you have multiples of pi over 2. So what that means is that it is best that we scale the x-axis starting with pi over 2. So I will go here 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2. I'm going to make this a little bit thinner. 6 pi over 2 or 3 pi, 7 pi over 2. 8 pi over 2 or 4 pi, 9 pi over 2. 10 pi over 2 or 5 pi, 11 pi over 2. 12 pi over 2 or 6 pi, and by now, as you can see, you have reached the length of the period. And knowing that the graph has shifted 3 pi over 2 to the right, it means that we need to go another 3 pi over 2 to the right of 6 pi, so we can end the cycle. So remember that this was 12 pi over 2, so the next value will be 13 pi over 2. We're almost there. 14 pi over 2, which is 7 pi, and then 15 pi over 2. So our graph is starting at 3 pi over 2. So I will mark this with a different color so that I will remember it better. Next thing we want to do is scale the y-axis. So as you can see in here, we have an axis of symmetry at 1, and the amplitude is 2. So we need to fit in a maximum of 3 and a minimum of -1. So try to maximize the space as much as possible. So which means that you have to check and see if you have enough space to fit 3 units. So in this case, then I'm going to say that this would be 1, this would be 2, and this would be 3 units, which will mark the maximum of the sign. And I will continue actually to draw the, to scale the axis. And that's because we are planning here to draw the graph of the reciprocal. And we know that the reciprocals go above the reciprocals will go above the primary here. So sorry, I'm going a little slow here, but -2 and -3 and -4, and I think we have enough room here, and -5. So next we are going to draw the graph of the axis of symmetry, or the graph of the axis of symmetry, because it is a line, right? And that is at y equals 1, and this is where the y equals 1 will be. And we will build the graph of the sine function on the axis of symmetry, so on this line. Now we know that the graph will start at 3 pi over 2. That would be the starting point. And it will end 6 pi radians later, because 6 pi is the period length. So 6 pi is in here, so we said that if you want to continue for 3 pi over 2 more, it means that you have to go 1, 2, 3 more units further. 1, 2, 3 more units further. So that means the graph of sine will end right here. So we're going to say that halfway the sine will have the x-intercept. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 little units in here from beginning to the end of the cycle. So that means we are going to go 1, 2, 3, 4, 5, 6. So 6 units somewhere here in the middle at 9 pi over 2. We'll have the next former x-intercept of the sine function. So that means that halfway the first half of the period, which happens to be at 3 pi, the function will hit a maximum of 3. So at 3 pi, we'll have the sine function equal to 3. And halfway the second half of the period, which happens to be at 6 pi, the function will hit the minimum value, which is -1. And here we have all the 5 points for the sine function, which is a primary, and we will shape the graph. Here we go. Now we are going to build the graph of the reciprocal, and this is the easiest and the most fun stuff, or part of the graphing here. So I'm going to start by drawing the vertical asymptotes. The vertical asymptotes are at wherever the intercepts are. Now remember that the points where the function will intersect the axis of symmetry will be like the x-intercepts, right? So right here at these points, the reciprocal will have the vertical asymptotes. So let me draw them here nicely. Good enough. Here we go. And one more. Oh, I don't like this. So maybe here. That's better. Okay, so the vertical asymptotes are at x equals 3 pi over 2, x equals 9 pi over 2, and x equals 15 pi over 2. And from here on, all you have to do is just build the reciprocal on the primary. So that means the primary is increasing, the reciprocal would be decreasing. So similar to what we did before, primary decreasing, reciprocal increasing. I'm going to make this a little thicker so that it stands out more. All right. And in the same way, here we have the next section of the primary. So it will be increasing and then decreasing. And voila, here we go. We got the graph of the reciprocal of sine, or in other words, we got the graph of 2 cosecant 1/3 x minus pi over 2 plus 1.